Okay, we have a little bit of bell work here. We're going to solve for x. So I suppose we should change this to an improper fraction. We multiply and add. So we get 17 over 8x minus 1 over 5 is equal to 5 times 5 is 25. And we're multiplying by 1 over 2 to the third, which is 1 over 8. And we're going to multiply through by something that will cancel the fractions out. I believe that would probably be the best thing to do. And the least common denominator is 40. So, well, I have an 8 and a 5, so that's 40. So let's see. We'll go ahead and say the 8 cancels with the 40. That leaves me with 5. The 40 cancels with the 5, and that leaves me with 8. There's nothing to cancel. Well, there is something over here. There's 8 on the bottom. So the 8 cancels. That 2 to the third, that's 8. And then we'll also multiply by 5. 25 times 1 times 5. And then you can go ahead and solve for x. The opposite of a number is tripled and then decreased by 7. Well, the opposite of a number is a negative number, and it's tripled. So we'll multiply by 3. I suppose I should just write negative 3x. And then decreased by 7, and the result is 3 greater, but I don't want it to be 3 greater. So then I'm going to add 3 to the other side, then twice the number. Okay, and you can solve for x. All the members of one set are also members of a second set. The first set is said to be if. I missed that little word. If all the members of one set are also members of a second set, the first set is said to be a subset of the second set. If we have the two sets, B has the elements of 1 and 2, and 2 has the elements of 1, 2, and 3, you can see that B is a part of A. A is bigger than B, but there's B right there inside of A. So B is a subset of A. And let's see, given the sets, it looks like just these whole numbers here, starting with 0. 1, it goes on. Looks like it just goes on forever. Got dot, dot, dot there. So this is A is all the whole numbers. Looks like B is, well, I was going to say even numbers, but then it stops at 6. So it doesn't keep going. And C looks like it's odd numbers that stop at 7. All right. So we say, is this true or false? Is B a subset of A? And you look and you say, well, A goes on forever. That's what these dots mean right here. It's all the whole numbers. Whole numbers are different from counting numbers or natural numbers because it has a 0. Okay? And no negatives, no decimals, but everything from 0 up forever. So we would say, yes, the fact that B starts with 0 and includes 2, 4, and 6, yes, we'd say that's true. And then you can think about these other ones.